In today's lesson, we're going to be learning about some exponent properties and laws of exponents, which you might have seen in algebra, but we're just going to kind of summarize them again because they apply to Algebra 2. So if you can get your heading on your paper, we're going to have 7 rules. We're going to have some examples just so you could see how these rules are applied, and then we'll be done. So if you're ready, the first rule, if we have 2 powers we want to multiply, like x to the a power times x to the b power, and they have the same base meaning this bottom, we can add these exponents to become x to the a plus b power. There's our rule. So what I'm going to do is bubble it, and then underneath I'm going to write add exponents. So when you have the same base, you can add the exponents. So I'm going to do some examples over here on the side. So I'm going to write examples. And I'll only write that once because I'll put our examples over here. So for example A, we'll start off fairly simple. We'll have x to the 10th times x to the 3rd. If we were to simplify that, if we add the exponents, 10 plus 3 is 13, so x to the 13th. Here's another example. Example B. If we have 5 x to the 4th in parentheses, and then next to that, 6x to the 3rd. These numbers in the front are not exponents, so we just multiply them like we normally would. 5 times 6 is 30. And then we have our x to the 4th and x to the 3rd, so that's the exponents we add. 4 plus 3 is 7, so we get 30x to the 7th. Here's another example. Can you write in parentheses x cubed y squared? And then after that, x to the 6th y. So here there's no numbers in the front, so we don't have to worry about those. We are going to add the exponents for the same base. So if I look at my x's, I have x to the 6th, x to the 3rd, and x to the 6th. 3 plus 6 is 9, so that becomes x to the 9th. If I have my y exponents, I have y to the 2nd power, but this y has an imaginary 1 as an exponent. So 1 plus 2 is 3, so that becomes y cubed. So that is rule number 1. Moving on to rule number 2. Just going to draw a line and write rule number 2. We've got 7 of them. So up here we were multiplying bases, we're multiplying powers and adding the exponents. Here we're going to divide. So if we have x to the a over x to the b power, if they have the same base, we're allowed to subtract the exponents. So that's the same as x to the a minus b power. So I'm going to bubble that. Anytime we have the same base, we can subtract. And underneath, I'm going to write subtract exponents. Subtract exponents. So I've got a couple of examples here. So for example A, I'm going to put 6 x to the 10th y over 12 x to the 4th. So now these integers they're just a regular fraction. So I'm going to take these two and ignore my exponents for a second. I have to think of a number I can divide into both of those. I can divide both of those by 6. So I'm going to divide the top and bottom by 6. So the 6 becomes a 1 and the 12 becomes a 2. Now I have my powers here, my base that has the same base. So if you look, I'm going to apply this rule. I'm going to subtract the exponents. 10 minus 4 is 6. Another way to look at it is, where's the most amount of x's? There's 10 on the top and 4 on the bottom, so there's 6 more on the top. So I get rid of the bottom, and I'm going to change the top. I'm going to cross it off and write x to the 6th since there were 6 more. If there were 6 more on the bottom, I put them on the bottom. So that means our answer, we have left on the top 1x, x to the 6th. We don't need the 1, so it's just x to the 6th. On the bottom, we just have a 2, no letter. Example B, one more. If we have x to the 6th, y to the 3rd, and on the bottom, xy squared. we are comparing exponents of the same base. So if I'm looking at my x's, I have x to the 6th on top and I have x to the 1st on the bottom. That's an imaginary 1. I subtract the exponents. 6 minus 1 is 5. There are 5 more x's on the top. So I cross off the x on the bottom and I change the top to x to the 5th. Notice I'm not just crossing off the exponent, I'm crossing off the letter so you don't think it's a number in the front. If I look at my y's, there's one more y on the top. 3 minus 2 is 1. So I get rid of the lower one, the smaller one, and I change y cubed to y. Now we're ready for our answer. On the top, I have x to the 5th, and we have a y, and there's nothing else on the bottom, so we're done. Next rule, we're going to do rule number 3. My little line here. Rule number 3. We'll go a little bit quicker. If we have a negative exponent, there's something that we can do with it. So if I have x to the negative a power, what that means is it's the same as x to the positive a, but you put a 1 over it. So all you do is just move it to the bottom. So anytime you have a negative exponent, you put a 1 on the top and the exponent becomes positive on the bottom. So this is our rule. We do a couple of examples. So here's example A. If I have 2 to the negative 3rd power, because it's a negative exponent, I put 1 on the top. I move this to the bottom and make it positive. So 2 to the 3rd power. I can actually simplify that. 2 to the 3rd power is 2 times 2 times 2. That's 8. So it's the same as 1/8. Example B. If I have x to the negative 4th power, again, the negative exponent means that you're going to put 1 on the top, and you move this to the bottom and make the exponent positive. So it becomes x to the 4th. There's nothing else we can do with it. One more, example C. If we have 4x to the negative 2 power. Now, the 4 does not have an exponent. It has an imaginary exponent of 1. So that is going to stay on the top. That is not attached to this negative 2. So the 4 stays on the top. Because this x has a negative exponent, it moves to the bottom and you make it positive. So positive 2 is an exponent. This is our final answer. So you only move what has the negative exponent. All right, on to rule number 4. I'm going to take this off. Rule number 4. If we have x to the 0 power, you can grab your calculator and try it. Anything to the 0 power. If I do 2 to the 0 power, if I do 8 to the 0 power, if I do 25 to the 0 power, it always gives you a value of 1. So anytime you see a 0 power, it equals 1. So we'll do a couple of examples. Here's example A, 5 to the 0. Well, we just said anything to the 0 power is 1, so that answer is 1. Example B, if we have 3x to the 0 power, the answer is not completely 1. This exponent's only attached to the x, so we bring down the 3. X to the 0 equals 1, so we are changing that x to the 0 to 1. 3 times 1, that gives us 3. So you remember the exponent only goes with the term that it's attached to, or the variable. All right, next rule. This will be rule number 5. We've got 7. Rule number 5. If we have something that says x to the a power, and then on the outside, in parentheses, we have another exponent, what we do is we multiply those exponents, so it just becomes a times b. So can you write x is x to the a times b power? So this is our rule. Anytime you see an exponent on the outside, you multiply the exponents. And I'm going to write that underneath. Multiply exponents. Multiply exponents. I'll give you a couple of examples of those. So if we have in parentheses x to the 10th power, and then on the outside you have a 3. This 3 gets multiplied by all the exponents. So 3 times 10 is 30, so it becomes x to the 30th power. Example B, if you have in the parentheses x to the negative third power, and you want it to the fourth power, remember the first thing you would do is multiply. You can take care of the negative later, but we're going to simplify first by multiplying to have only one exponent. So negative 3 times 4 is negative 12, so we have x to the negative 12. According to rule number 3, you cannot leave a negative exponent in your answer, so what we're going to do is put it over 1 and make the exponent positive. So we're going to take this and put 1 on the top and change x to the negative 12 to x to the 12th power. There's your simplified answer. 2 more rules. Here's rule number 6. Rule number 6 is very similar to rule 5. If we have a couple of things inside the parentheses, like an xy, and we have an exponent on the outside, you are just giving this exponent to both of them or multiplying both exponents if there's imaginary exponents or exponents there. So this is the same as x to the a power and y to the a power. You give that exponent to both of them. So that is rule number 6, and we'll be referring to this. Here's some examples that practice that rule. Here's example A. In parentheses, if we have x cubed y, and then the outside to the 4th power, we are multiplying, we're giving this 4 to both of these exponents. Because this has an exponent, you multiply. 3 times 4 is 12, so the x becomes x to the 12th. This y has an imaginary exponent of 1. 1 times 4 is 4, so this becomes y to the 4th. So there's your simplified answer. Example B, one more. If you have 2x squared inside the parentheses, and then you have an exponent of 3 on the outside, you don't just change this to 2x to the 6th. You have to give this 3 to every one of these. So you're not doing 2 times 3 because 2 is not an exponent. You are doing 2 to the 3rd power. Then we are giving this exponent to the x squared. Well, we multiply the exponents. 2 times 3 is 6, so we get x to the 6th. We can simplify this one more time. 2 to the 3rd power, that would be 2 times 2 times 2, that's 8. So we have 8x to the 6th. There's our simplified answer. One more rule. I'm going to switch to a new paper just so we have enough room. Last rule. So this is rule number 7. If we have a fraction and it looks like x over y in parentheses, and then we have an exponent on the outside, just like rule number 6, we are going to give this exponent to both the pieces in the numerator and the denominator. So this is the same as x to the a power over y to the a power. So this is our rule. When you see this, the exponent goes to both. So here's an example. If I have in parentheses 3 over x squared, and I have a square on the outside, I need to give this exponent to both of them. So this 3, I do not do 3 times 2. 3 is not an exponent. I'm going to do 3 to the 2nd power. I want to do x squared to the 2nd power. So remember, you multiply exponents. 2 times 2 is 4, so we have x to the 4th. I can simplify this because 3 squared is 3 times 3, that's 9. So we have 9 over x to the 4th. Another example, example B. We've got a fraction. On the top, we have negative 2 x squared y to the 5th. On the bottom, we have 3z cubed. That is all in a set of parentheses with our 3 as an exponent on the outside. So what we need to do is give this exponent of 3 to the top and the bottom, but every single piece that we see. So on the top, I need to give this 3 to everything. So this negative 2 becomes negative 2 to the 3rd power. I'll simplify it later. This x squared, remember, multiply exponents. I didn't multiply these because they're not exponents. 2 times 3 is 6, so x to the 6th. Y to the 5th if I do to the third power, 5 times 3 is 15, so y to the 15th. On the bottom, I need to give this 3 to everything. So this 3 becomes 3 to the third power. This z cubed, 3 times 3 is 9, so it becomes z to the 9th. I can simplify it because I can change these numbers. So in my calculator, if I do -2 to the third power, notice I put it in parentheses, I get -8, so we have -8 on the top. I don't see any letters in common, so I'm just going to bring my letters over. If there were some in common, I'd cancel. 3 to the third power, that would be 27, so I have 27 z to the 9th. There are no numbers that go into 8 or 27, so I am done with my answer. Those are our rules. We will do some practice examples when we do the practice assignments the following lesson. Please make sure to submit your notes into Canvas to get credit.